Alright, in this video we are going to go over the steps of adding and subtracting rational expressions. So for example, adding and subtracting 1 over x plus 5 plus 3 over x minus 1. And I'm going to give you the steps, and as I go through the steps I will do the problem. So let's go through the first step. Alright, so step 1 is we are going to find a common denominator between the two addends. So I have here x plus 5 in my denominator here, and I have x minus 1 in my denominator there. I need those to balance each other out. So in order to add fractions, the denominators have to be the same. That is one of the most important things of adding fractions, is getting those denominators the same. So if I were to go and balance these out, the right side here needs an x plus 5. So what I'm going to do is I'm going to add an x plus 5 over x plus 5 on the right side. And then to balance the left side out, I need an x minus 1. There we go. So then, after you have that common denominator, you need to multiply that through. So we're going to simplify the expression by multiplying through, so I'm going to distribute that 1 through here, so I have 1x minus 1 over x minus 1 times x plus 5 now. That's my new denominator, which is what we wanted to do. And then I'm going to distribute that 3 through here. I have 3x plus 15 over x minus 1 times x plus 5. Notice now that I have the same denominator on both fractions. So there's going to be one last step here. Alright, step 3 is to perform the addition or subtraction operation. So now that they're both the same, it's like saying x minus 1 apples plus 3x plus 15 apples, and you just combine the like terms there. So, I have this plus this, and that is what we are doing. And then after we add that, the denominator stays the same. So we've got 1x plus 3x is 4x. Negative 1 plus 15 is 14. And then we keep the denominators the same. And that is the final addition of that rational expression. Now it's good to look and see maybe if something would cancel out. You should check. If I were to factor the numerator, I'd factor a 2 out. I'd end up with 2x plus 7. None of that would cancel out with the denominator. So we are good, and that would be our final answer. So let's look at a couple more problems, and then we'll look at some complex fractions. Alright, so here's the addition. Now there is one step I kind of forgot to mention in the last steps, and that is if your denominators can be factored, you do need to factor them first. So let's rewrite this with our denominators factored. That would be x plus 1 times x plus 1, or you can write x plus 1 squared. And then plus 4 over x plus 1 times x plus 4. Alright, so we need to balance out our denominators here. So on the left side, I have x plus 1 times x plus 1. And on the other side's denominator, I have x plus 1 plus x plus 4. Now over here, on this side right here, we're missing this x plus 4. So we need to multiply the numerator and the denominator by whatever that side is missing. Now on my right side here, I do have an x plus 1, but I need x plus 1 squared. So to balance that out, we need one more x plus 1. If you think of each individual term as a weight, I'd have only one weight here, but I have two of the same weight there, so I need one more weight to balance it out. Alright, so after we balance out the numerators, or from the denominators, let's go ahead and multiply each of those terms through. So I end up with x squared plus 4x over my denominator, which I'm just going to write x plus 1 squared times x plus 4, because I don't want to keep writing it. Plus, and now let's balance this one out, 4x plus 4 over x plus 1 squared times x plus 4. Okay, we're just going to go through now and combine like terms and perform the operation. So I'm adding. I'm going to add the numerators together and keep the denominators the same. Just think of it if I had 1/2 plus 3/2. You don't go 4/4, you go 4/2. It's like a unit, the denominator is in this case. So I have x squared, and then I have 4x plus 4x is 8x plus 4, all over x plus 1 squared times x plus 4. And we are done. Now I'm just going to think about really quick in my head, if that top part would factor, would that reduce with any of the things on the bottom? But the top doesn't even factor, so we are good. Let's look at one more that's a subtraction problem. Alright, x squared minus 2 over x squared plus 6x minus 7 minus 19 minus 4x over x squared plus 6x minus 7. Alright, so I did a little something. If you look at the denominators, we could factor them, but are they the same already? And since they already are the same, you don't have to have a common denominator. So then we can just perform, once the operations are the same, we can perform the operations we need. We have x squared minus 2 minus 19 minus 4x. So that ends up being x squared minus negative 4x is plus 4x. And then negative 2 minus 19 is negative 21. Okay. Something interesting happens here, I believe. So let's go ahead and factor that, just so you can see what would happen. If I factored the numerator, it would be x plus 7 over x minus 3. And then if I factor the denominator, I have x plus 7 over x minus 1. So this problem, we didn't have to do the hard part of finding a common denominator, but we did have our final answer, and it did factor. So I factored it to see what would happen, and it turns out that the x plus 7s will cancel, and our final answer would be x minus 3 over x minus 1. Okay? So there's something a little fun and unique that you can see. Alright, let's go over what a complex fraction is first. A complex fraction, if you look at this problem, has a division sign, and you have a rational expression on top of the division sign and a rational expression on the bottom. So you have multiple division signs inside of a fraction. Alright, so the first thing you want to factor if you need to. In this case we don't. And then the second thing is to determine the least common complex denominator. And you do that by finding the complex part, the denominator in the numerator, and the denominator in the denominator. And you're going to multiply every term by that least common complex denominator. So in this case, my LCD is x plus 5 and x minus 2. So I'm going to go through and I'm going to multiply every single term by x plus 5 times x minus 2. Alright, and I'm going to multiply this term and then this term right here. So we have x plus 5 times x minus 2. And we'll distribute that there and there. Now this is the most complex part of the problem, and you really do it right at the beginning, so that's nice. What I have here is this x plus 5 will cancel out there. So I've actually eliminated my complex fraction. So let me use a different color so we can see that. So you have 2x times x minus 2. You've eliminated the complex part on the top. Now let's look at the denominator. We're going to have to multiply this group right here by both pieces in that complex expression. The x minus 2 cancels out of that first one, and I have 7 times x plus 5. And then minus 1, nothing cancels out because I don't have a denominator, so we're going to times that, x plus 5 times x minus 2. Alright, and we just need to make sure that we do step 3 then. So we need to distribute anything that needs to be distributed. This is kind of the annoying step. When you already have the fractions eliminated, now we're going to distribute anything through, so we end up with 2x squared minus 4x. And then on the bottom I have 7x plus 35. I need to FOIL that through. So I have minus, I need to FOIL, that's x squared plus 3x minus 10. Alright, so the last thing is just combine any like terms. I have 2x squared minus 4x over, so I have 7x minus 3x, which would be 4x. 35 minus negative 10 is plus 45, and then minus an x squared. And I'm just going to keep that minus x squared at the end because it's a minus. And that is my final complex simplification. I really started out with a hard one right at the beginning. Let's look at maybe one more so you can see.